You've connected to Cisco Unplugged.
Hello, everyone, and welcome to Cisco Unplugged. I'm Dan Klamert, your host. I'm back here with Al Dumdei. How are you doing today, Al?
Hey, good, Dan. How are you?
I'm great. Thanks.
Good. But The,
And this
the
week on
session
episode
today,
six, what was that? Sorry.
the session today reminds me of Hogwarts, right? So it's like we got Professor Dumbledore here. We got, all of the greats from Hogwarts here today. So the
Exactly.
Wizards of Wi-Fi.
The wizard. Exactly. Exactly. Yeah, no, that's true. So this week in episode 64, we're back for part two, what Al's talking about, of the wireless packet captures deep dive episode that we did a few episodes back. And we're lucky to be joined again by, welcome back, Dan Davis and Ian Procyk. How are you guys doing?
Doing well today, Dan.
Good to see you.
And the same here.
All right.
Yeah,
Thanks
you
for
guys have
joining
to
us.
pick titles, right? So one of you has to be Dumbledore and one of you has to be Hagrid. Just kidding.
Roll the dice, Sal.
Roll the dice. No preference there. So, first, before we get started here, I got a few reminders here. We do use Slido. Now, when I logged into Slido this morning, I did see that they're reporting some downtime issues here, but it looked fine for me. But if you have any issues, we do also monitor the YouTube chat. So if you are, again, watching on YouTube, we do stream live on YouTube. It's youtube.com/@getunplugged. And the link to Slido is below the video there. And don't hesitate to answer or ask questions. We've got people standing by. We usually jump in live on the show as well to ask those questions. But I know the last episode we had quite a bit of questions coming in here on the cloud side of packet captures. This time around, we're going to be focused more on the on-prem and Catalyst Center side of packet captures. But let us know if you have questions. Hopefully Slido holds out here and it works. So let's go ahead and get unplugged here. Dan, why are packet captures so valuable? Let's talk about that again.
Yeah, that's a good call. So we mentioned that on the Meraki call when
Yeah.
we did the round one. And what I like to think about is if you're in Boston and you're supporting an office that's maybe out in California, you can hop on a plane. Maybe that's what you want to do, but it's a lot easier if you can remotely trigger a packet capture as opposed to having boots on the ground. I think that really sticks out as being one of the big reasons. Another one I think is client roaming. These clients like to roam, and sometimes it's between access points that are on different channels, maybe even different bands. So you have to have some different capabilities from a capture perspective to be able to support that. You also have to, be able to decrypt packets. Not all the time, but you might want to look at it from a forensics standpoint. So the decryption is important, or maybe just want to see what type of applications are being used over the wireless network. And then, in the past, I have a triple blendy kit here, as I used to call it, and I'm in my office today. So got a nice Pelican case I kept it in. And when you open it up, I've got lots of adapters in here. I had three of them. That was my multi-channel
Mm-hmm.
triple blendy scenario, but these are 5 gigahertz and 2.4 gigahertz adapters. In order to keep up on the technology, we've got, the 6 gigahertz band now. So you've got to make sure that you go out and update your sniffer. So if we can integrate that into the product, that's something that the engineering and IT staffs don't have to worry about.
That's great. Yeah, it looks like Slido is working here. We had a comment already from Anders, Harry Potter and the Mystic packet captures. So, I forgot my butter beer this morning here. I maybe
Yeah,
have
I
to
love it.
go get one.
Yeah. So the other thing, Dan, and we mentioned this last time, is now with WPA3 and management frame encryption, even if you pull out your triple blendy, you're not going to be able to see a lot of stuff,
Yeah,
right? So
Yeah.
your triple blendy is, it's time to put it back in that case and bury it.
I know. Yeah, it's got dust
I
on it,
know.
believe me, it does. And OWE is another one, even the guest networks today. With Wi-Fi 7, what a lot of customers are doing is setting up a separate guest SSID for OWE. And they're using that Diffie-Hellman key handshake, so you don't have to set up anything on the client, but your guest traffic now is encrypted. Never was like that in the past.
Mm-hmm.
Yeah.
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 So let me start off by just talking about the support that we have for packet captures. Okay, and this is for Catalyst Center. This is our on-premise product.
Mm-hmm.
And we've got support on, the AirOS controllers, which are, a bit long in the tooth nowadays, but the support is there. And then, of course, on the 9800s, and we've got a new 9800. We did a hardware refresh on that platform, so that, of course, is supported. We've got the versions at the top listed, and then the different modes. We've got Flex Connect mode for the branch office scenario. There's Fabric scenarios if you want to do embedded security in the network, and then traditional local mode as well. So we've got that covered, all modes. And on the bottom, I just listed out some of the different versions of iOS XE in the 9800 and some of the different features and functionality that we've added. If you're, say, on version 17.9 and the over-the-air packet capture is of interest to you, well, maybe there's an upgrade to 17.12 in your future. And then the architecture, this is kind of what it looks like. Three main components here, no surprise. Got an AP wireless LAN controller and Catalyst Center, also sometimes called DNA Center. And we've got the location data that's being sent at the top. Today that includes, in some cases, BLE RSSI data, or Wi-Fi RSSI data, or on the new Wi-Fi 7 APs, ultra wideband data. And then client data. That's the yellow line there in the middle. That's your events. Like maybe there's a client that's doing the authentication, getting onboarded, going through association, authentication, DHCP. Those events are sent up as shown here. Automation and configuration of this is done through Catalyst Center, so it's centralized, and we use the TLV protocol to do that. And I think most interesting on this diagram is the intelligent capture data path. And that's our branding for the packet captures. It's ICAP or intelligent capture. And you can see here that the AP has a direct line to Catalyst Center. It bypasses the wireless LAN controller. And the reason we're doing that is really for speed and freshness of data. When you start looking at PCAPs, or maybe it's signal strength from a client, you want it to be as real time as possible. So you're not going through the controller, adding any latency or buffering. And we're doing that through a TCP port, and we're using a Google remote procedure call. So if you've got internal firewalls, just make note of that. You do have to have that path open if you want to use the intelligent capture capability.
I think this slide is particularly important if you're troubleshooting, right? Because if you're not getting packet captures, you might want to check, for example, that gRPC connection, because you may not have thought that you need gRPC between the AP and Catalyst Center, right?
Yeah.
I mean, normally you think, okay, I need, my traditional CAPWAP ports, between my wireless LAN controller and my AP, especially if you're doing something remote, right? So, yeah.
That's true.
Just
And doing some testing, I've had some times where I didn't enable something that shouldn't have been enabled, and it'll come up and say gRPC link not connected. And I know what that means, but that's the reason I put it up here, so everybody else would understand it too.
Yeah, that's good data.
Yeah. So when looking at Catalyst Center Intelligent Capture, there's 4 items that I want to go through, and these are all 4 features or 4 pieces of functionality that exist on Catalyst Center. There's a 5th one too that I'm going to touch on. It's not on this slide. It's a little bit of an out-of-band method where we're not using Catalyst Center. We're using the controller in the AP Direct. But let's start off with number 1, anomaly-based packet capture, or anomaly-based PCAP. What we're doing here is all the APs are listening for anomalous behavior. And what might that include? Well, it's really focused on client onboarding. So you've got from an 802.11 perspective, the client has to associate, he's got to authenticate, go through layer 2 connectivity and encryption. Maybe there's WebAuth involved, a DHCP. There's lots of different things that need to happen for that client to get onto the network. And if something goes wrong, we've got a lot of different events that will automatically capture and trigger. We capture 100 packets, around 100 packets. So we'll capture packets before the event and then after the event, and then show you what the event is. And you can see I've got a little diagram here that shows IP learning. There's a PCAP icon next to that, which means that, yeah, the AP automatically captured some packets, and we allow you to view those. So I'm going to jump out of this presentation and take a look at Catalyst Center to give you a little bit more insight into this. So here I'm at the main menu of Catalyst Center. And if I go into, let's say, Assurance, Health, and then Clients, I've got a main client page here. But if I scroll down, it's going to give me a list of all my clients. I've got a lab environment here, so just a couple clients on it. If I look at my desktop, you'll see the Intelligent Capture button right here. I'm going to go ahead and select that. And I'm going to change the time frame to 5 hours, so it brings in a little bit more data. So the anomaly packet capture is really what you're seeing right here in these onboarding events. And some of these events have gone quite well. They're green. This DHCP event has got a green dot. All is well. It's just letting you know that the DHCP process happened. But then the anomaly PCAP is where we're really trying to help you out. You can see here that there was a problem with authentication, and we captured that. And then we've got a PCAP icon next to that, and that's indicating that there's some additional data that we've got for you. And if you look right here, you can see that it's telling you the client desktop failed to connect due to the 4-way handshake. And then there's also, additional data. You can scroll down if you select it. Let me say here. Okay, let's see if I can. Yeah, so I'm getting. Try it one more time here. Yeah, so I'm looking for a packet viewer, which I'm not seeing, but what you do get here is RF statistics coming in. So these statistics are bringing in this particular case, you've got received signal strength and SNR. And this is coming in at a relatively decent clip, but notice up here, there's a little live icon. It's grayed out, so it's not saying it's live, and it's a little confusing because data does come in, but it's not coming in as fast as it could. Okay, and I'll get to that and how to change that as we progress into this. Now over here, there's also a live icon, and you can see it says 3-minute delay. We can improve the rate at which the data is coming in for both of these, and that's going to be the next piece. Okay. But now if you want to see this actual packet capture, you can click on one of these that's got a PCAP up, and then you can download that and view it in Wireshark. There's also a viewer within Catalyst Center. It's not a Wireshark viewer, but it does allow you to view kind of the packet, and whether it came from the client, whether it came from the AP, what your signal to noise ratio is, what the inter packet delay is as well.
Hey,
Now,
we have a question here, and I just wanted to. It's specific to APs, and it's around what types of APs. Are there any limitations in packet capture in newer APs? I.e., the 6E and beyond APs. But also, what about older APs like Wi-Fi 6, like the 9105 specifically?
Yeah, we have the ability to do anomaly packet captures on all those APs.
Okay.
There are some cases where it was only the top tier APs that allowed us to do like a full packet capture.
Mm-hmm.
And that one of the things I'm going to show as I progress into this is the full packet capture.
Sure.
So you do have to kind of be aware of that. Like the 9164, for example, didn't support full packet capture, but the higher tier 9166 did. And there's also some scenarios. Yeah, go ahead, Al.
9120s and 9130s, same kind of thing, right? 9120s didn't support it. The 9130s did, if I remember right. So
Yeah. Now, when you get to the newer APs, like the 9176 and the 9178, that's no longer the case. You know, they all support the full packet capture. So we've kind of moved away from that restriction.
Okay,
Then,
thanks. Yeah, that's a good explanation. I appreciate that. We also have another question around the, I guess we'll call it monitoring catalyst controllers in the Meraki dashboard. And we've talked about in the previous episode Meraki APs and intelligent capture. What about catalyst controllers monitored in Meraki dashboard without DNAC in the picture? Is that supported, and does GPRC, come into play at all in that case?
well, if the Catalyst controller is a wireless LAN controller, yeah, we can do monitoring of the wireless LAN controller within the Meraki dashboard. I know they're going to include packet captures in that, but I'd have to look and see if that's there yet.
Okay.
Maybe,
Okay.
Al, have you
this is packet captures directly on the controller. Is that, I mean, on,
well,
I
if
think
you've
they're
got a
asking about
controller,
in the dashboard, but through the controller, monitoring catalyst
oh,
controllers
so
with the
cloud monitored
dashboard.
controller. Yeah.
Yeah.
I don't think that's there yet.
Okay.
Yeah, I don't think so.
yeah, they plan on adding it, but not
Okay.
yet.
Thank you.
Now, when you look at the data we have here, you'll see, there's the ability to grab these anomaly packet captures, and I also showed you the RF statistics. So these two pieces do need to be enabled, and let me show you some of the setup that's required. So if I go back here to the main menu, under settings, there's an intelligent capture setting, and if I go to access point, so AP stat capture, that was that RF data that was coming in. And the reason, that's coming in is because it's enabled here. And it's going to be enabled at the controller level. You can see here that I do have it enabled on my 9800. And then the anomaly capture, if you want to have it actually trigger on anomalous events and pull in those 100 packets, then anomaly capture does have to be enabled as well. And you can enable this on, up to 3 controllers. The AP stats capture is across up to 1,000 APs. So if you wanted to, say, enable it on specific APs to make sure you got the 1,000 APs you want, there's a little radio button here that would allow you to do that. But I would say, in general, if you're going to do, intelligent capture, if you're going to use that functionality, I would have both of these enabled, allowing you to get the full visibility of the packet captures. And I'll take another look and kind of show you again what those correlate to. So intelligent capture. And so that one radio button, or that one configuration, is going to allow you to enable this. And then the other one would actually allow you to have this data come in. And this is coming in over that gRPC link, and so are the anomaly PCAPs. Okay. So that's the anomaly PCAP piece of this. Now, if I go back to the presentation here, the next one is called onboarding captures. And I've got a little note in there that says same as scheduled. So if you read through the documentation, it does at times get a little bit confusing because they'll use those two interchangeably. So let's take a look at Catalyst Center again. If I go into the configuration section again, intelligent capture settings, you can see that on onboarding packet captures, that's what I've got selected right now. Scheduled packet captures, I have not run any, but over here, scheduled client capture. So if I wanted to, I could put in, the MAC address or the IP address of a particular client, select my controller, and then go ahead and schedule this packet capture. Now, this packet capture is very similar to the one that I just showed you, but there is one difference. And what it is it changes the timing. So if I go to intelligent capture, and I go ahead and do run packet capture, onboarding packet capture. That's what we're focused on here. I can say next. I'll apply this. And what this is going to do is it's really just going to increase the timing, how quickly the data is coming in. And right now it's just going through the process of building out the configuration. And then it's going to go ahead and let me push that configuration down to the controllers. Might take a minute here. You can see the configuration is there available if you're interested in that. So I've pushed that down. And now after you do that, what you'll notice here is this live icon now is highlighted in blue. It's no longer in gray. And it's telling me that I've increased the cadence that this data is coming in now from the AP. So if I'm really zeroing in on, say, RF statistics or the data rates, and I want to see that quicker, now I can. Over here, it's coming in now at 20 seconds. Okay, before running this, it was 3 minutes. Okay, so that's what happens on that particular option. Now, if I move to the next option, this is the full packet captures. So a full packet capture, what we mean by full is that it collects, not only management frames, but it also will get, data packets and beacons as well. And this is going to be run for a single client. So if you're doing troubleshooting and you've got a client under test, maybe it's a client you're watching, you would want to, go ahead and do a full packet capture. And we do decrypt on this. So if you've got encryption, like if you've got like a pre-shared key or something, we can show you the decrypted packets. And then if it's a roaming scenario and the client moves from one AP to the next, then we will actually follow the client as it moves and slice in those packets together and allow you to view it in one Wireshark packet capture trace. And the way that would be initiated, jumping back into Catalyst Center, is I would come over here and then health again, client, and back to this client main page. And scroll down to this client under test, intelligent capture. And then the run packet capture. And here you can see full packet capture. So you would select that and then select the duration. How long do you want this to run? And then the controller, and then go through and, next, and it would go to push the commands down to the controller and start that full packet capture process. And then if you want to see a full packet capture, again, we store them over here in the settings section. So if full packet capture, you can see I've got a full packet capture that was collected previously, and it's kind of given me the list of all of these right here. I can select this packet capture, and it'll bring it into scope under the Client 360 menu. And then if you want, you've got the ability, to download these and view them in Wireshark. And in this particular case, there are beacons in there. That's a feature that we added. Because a lot of times you want to look at beacons to understand client connectivity or client issues. So that's the full packet capture. And then we've got another one, the last
Dan.
one. Yep, go ahead.
I'm sorry. We got some more questions here again here. I just want to jump in here. Virtual Tony via YouTube is asking, is there any difference between the AP mode? So if we're in local mode versus Flex Connect, what are the differences there? Or any limitations?
Yeah, there's not. From a packet capture perspective, we support local mode and Flex Connect mode. We also support if you've got a fabric setup using software-defined access.
Okay.
I might suggest one thing to think about in Flex Connect, especially if you're in a branch type of scenario and you have a limited WAN. You're going to be at the whim of that WAN circuit for packet capture. So if you're high bit rate, and this applies just to general, even sniffer mode, which we'll talk about in a minute here, but that's something you need to consider versus traditional campus where everything is, gig plus connectivity.
Well,
Yeah, I'm glad you brought
also
that up, Ian. That's a good
gRPC.
Oh,
right?
sorry, Al, go ahead.
It's not tunneled through the CapWAP. It's gRPC data in that case, right? So
Right.
you'd have to have some kind of a tunnel set up outside of the CapWAP
Yeah.
tunnel for that. So,
Yeah.
Yeah, that's a great transition to this next question from Brock in Slido is if DNAC is basically remote, I'm glad he asked this too, because I was thinking about asking this on that architecture slide earlier. Are there considerations with bandwidth related to pulling this data over the WAN, or is it simply metadata?
Yeah, I mean that if you think about like a traditional sniffer situation where you're running full blown, want every frame on the air coming into the system, absolutely. If you're doing anomaly based packet captures where the AP is basically just forwarding that first few hundred packets, I don't think that's a big deal. And we have a 100 meg buffer, I think it is, Dan, right, on the system. So that depending what you're doing, that you may burn through that pretty quickly, anyways, if you're in a busy environment. General rule of thumb: if you're trying to work an issue, I think you want to try and simplify things down to the point where you're isolating the clients under test rather than trying to capture everything and sort through that, right?
right. I agree.
Yeah, Ian, you're perfect at teeing up these segues here. The next question is, what if I need more than 100 meg?
Dan, I'll let you answer that one.
Yeah, it'll collect 100 meg, and then it'll collect 100 meg again, and we store these on Catalyst Center. And then at Catalyst Center, the way it works is once the space allocated for these packet captures becomes full, the last one you captured is deleted.
Got it.
But generally, the packet capture numbers you're going to have like 20 or 30 of these before you drop that old one. I haven't really seen it as being a problem. Archive if you need to.
Sure.
Yeah, so this option here is the over-the-air packet captures. So in this case, I got a diagram that kind of shows what's happening. In this case, the Catalyst Center is used to put an AP radio, not necessarily the entire AP, but a radio within the AP, meaning maybe it's the 2.4 gigahertz radio, the 5 gigahertz radio, or the 6 gigahertz radio into a sniffer mode where it's just listening to the channel. So let's say you had a third-party AP and it was a rogue AP, and you wanted to see traffic from that on channel 6. That sniffing AP would pull that in to Catalyst Center and allow you to view those packets in Wireshark. And it runs for 15 minutes, and I can kind of show you how that's initiated through the GUI here. So if I go back over here and say run packet capture, I would say, over the air sniffer. And it brings up a location map. And in my particular environment, I do have our Spaces location engine integrated into Catalyst Center. So we've got a location engine that's out in the cloud, and it's allowing me to triangulate and figure out my client XY position. And it's bringing up this map that you're seeing here, which includes the clients. If I scroll down, you'll be able to see I got a couple clients here in their location, and that's data coming in from the Spaces product. So what I can do is pick one or two APs here that I want to do an over-the-air capture. And, it's going to select one of the APs for you. It's going to select one that is the best candidate based on, what it hears the client from an RSSI perspective, or, whether the client is actually connected to that AP or not. So you can see here, it's selected the 9166 and not the 9136. And it's done that because this client is connected to the 9136. Right? And it would be disruptive to the client if I knocked off that client to turn the radio that it was connected to into a sniffer mode AP. Now, if you want to select the AP, you just click on it, and it comes up with a little blue checkbox there. I just deselected it. So when you look at the AP that is selected here, it does give you a clue to what I'm going to show you in the next menu. So radio 0 is 2.4, radio 1 is 5 gigahertz, and radio 2 is 6 gigahertz. Now, if I scroll down, the next step is to go ahead and pick the band that I want to select for capturing, and then what radio. And as I just showed, 0, 1, and 2 correlate to 2.4 gigahertz, 5 gigahertz, and 6 gigahertz. So in this particular case, I've got, a couple bands enabled, so I could do 2.4 or radio 1, 5 gigahertz. I'll just leave it on radio 1. And the channel width, 20. And if I scroll down more, it'll allow me to select the actual channel. So it's pretty specific. And then after that, next, loss of connectivity for the client. And then you would go ahead and push this configuration down to the controller.
So this is really akin to, we've had the sniffer mode on APs for a long time. It's just that you had to set up a separate capture location and all that sort of stuff, right? It was kind of a manual process. This basically the same thing, just automates that, right? Is that?
Yeah. Yeah. And thank you for that, Al. That's a good call out. That's exactly what we're doing here. And we're allowing you to see the channel, everything in that channel. In the past, we've got like a full packet capture. This is where we're pulling data out of like the buffer of the AP and stuff like that. This is just looking at the channel, which sometimes that's what you want.
Right.
I'm going to go ahead and deploy these configurations. And if you go into the wireless LAN controller, you can kind of see, I'm going to move this out of the way. This is a 9800, and just let me show you a couple things here. So if I go into configuration to the AP join, there's a section in the join profile called ICAP, and you really don't have to be concerned with this because Catalyst Center will enable it for you. But I like to look at this just to understand what Catalyst Center is doing. So you can see here when I enabled that anomaly detection, that's what it did. It enabled it right here. When I enabled the RF statistics, which we call AP stats, it enabled it here on the wireless controller. Here's the full packet trace. That's not running right now. Then the partial packet trace, that is running. You can see all the management type entities that are captured when you do the anomaly PCAP. So that's good. It's a good reference to understand where that's done in the controller. Then you can also look at the AP itself. If you go over here and you look at, say, the 5 gigahertz radio of a 9136, it says sniffer, right? So this AP has been put into sniffer by Catalyst Center. Another check, another way of checking to make sure that Catalyst Center did what you thought it should do on the controller. And then the other option, kind of getting outside of Catalyst Center. This is an eye chart. That's for your reference. That's what APs support full monitor mode and what APs support monitor mode at the radio level. Those are really the last two columns or the last two rows. Now here is the last option, and this is a little bit different. So this is not Catalyst Center. This is where you've got just a wireless LAN controller and an AP, and you want to take some packet captures. Now, I said one AP, but I have seen customers where they'll kit this up, and maybe they have like a cart or something. They package it up. It might be 3 APs or 2 APs, so you can have that multi-channel in the roaming capability. But in this case, the way it works is you actually, you go into the AP via the controller configuration, and you put the AP into sniffer mode. Right, so we've got local mode, we've got flex connect mode, but you can also put the entire AP into sniffer mode. And then once you get into the radio level on that AP, let's say you're at the 5 gigahertz radio, because that's where you're having some problems, you can go into that 5 gigahertz radio and say, okay, I want to capture this channel at this, width, 40 megahertz, and I'm going to set it up so that it's pointing to the IP address of Wireshark. And you put that IP address right into the controller configuration. And then via UDP, I believe it's UDP, it sends that data over to Wireshark. And it doesn't send it from the AP, it sends it from the 9800 wireless LAN controller. So the 9800 controller is going to use the source address of the AP or of the radio and send that via port UDP port 5555 into Wireshark, allowing you to view it. And on Wireshark, you do have to do a little bit of setup. It's not that difficult, but we've got a great document. I put the URL at the bottom that goes through the step-by-step on how to set up Wireshark to view it. So it's a nice option if you don't have Catalyst Center.
Dan, there was a question that said, I use my laptop to do PCAPs. What am I missing to what the WLC brings to this? So what are your thoughts on that? Why would you not just take your PC, let's say you have built-in packet capture, your triple blendy back out here again? I think we kind of talked about this in the beginning, but
yeah, right. If your laptop is say a 6 gigahertz capable laptop, maybe you have some new APs, Wi-Fi 7 or Wi-Fi 6E. You're going to want to make sure you've got that covered. I personally had to upgrade my laptop to get that capability. And then roaming, if you've got a client that's roaming from AP to AP, and remember, sometimes clients roam when you really don't want them to, are you covering multiple channels? Does your laptop have the ability to pull in multiple channels without missing a packet? Right, because when you're taking
from multiple locations, right? Yeah, multiple locations, right? At the same time, right?
Right.
Yeah.
And then
I think the
decrypt.
Yeah, exactly. Good. I'm glad you brought that up.
Yeah.
Good. Yeah.
We'll decrypt some of these for you. A lot of times you don't have to have it decrypted. You can just look at headers and that's fine. But we will decrypt because the keys are known by the equipment from Cisco. And on your side, if you're just sending that into Wireshark, you can put the keys into Wireshark and do some decryption as well. We make it a little bit easier. So I think those are probably the big reasons. And then if you've got a laptop and you want to fly out to California with that laptop or put it into a package and send it to one of your peers, that'll work. But it's a little bit extra of could be really time consuming, depending on what the remote office looks like from a distance perspective. Yeah. And MLO is another one, right? Multi-link operation. That's the new stuff we're getting with Wi-Fi 7. With this scenario here, because we can have multiple, radios in a single AP with multiple bands, we can pull in MLO data. When you're doing something like a full packet capture, we're not there yet. We're really just focused on a single band. But that's another piece of the puzzle. It's Wi-Fi 7, right? You've got multiple bands out there, potentially.
Yeah. And that back to your encryption thing, there's also the issue with management frame protection now, right? With WPA3, it's mandatory. All 6 gigahertz will have the MFP on, right? So PMF, whatever. So it's all, so you're not going to get a whole lot from your laptop anymore.
It's getting harder. That's for sure. It's definitely getting harder. And I think that it's really up to Cisco as well as the other vendors to make sure this functionality is baked in and works well. Yeah. So that's the last scenario. Ian, if you want to speak to some of the practicalities of the packet captures, that would be great.
Yeah, absolutely. So this kind of winds the clock back a couple years. 2022, actually, working with this customer. It's actually where I'm sitting right now at this hospital. They were complaining during a migration. So they have AirOS controller. And they're going to 9800s, and the observation was that their 8821s, their Cisco Wi-Fi phones, weren't roaming very well, if at all, between access points. And so this immediately gets into TAC case land. It immediately gets into over-the-air captures, all the things that we're familiar with, and we ended up needing to go a little deeper than the tooling that we've been discussing on the call thus far. So on site we go. And I'll let you drive through to the next slide here. And I think we kind of outline the scenario. Whenever you're working these types of roaming problems, it's fundamental just to boil it down to the most simplistic thing you possibly can, right? Which is 2 APs. Let's just put these on 2 different controllers, right? In this case, we had one on the 9800, we had one on AirOS. Technically doing IRCM here, but nonetheless, worked just fine in AirOS, and we were having all these problems on the 9800. So what's going on? So we just set up this in the basement of the building. We're away from everything else, just 2 APs. We could do our testing. And I captured a little bit of a video here, and I'll let you play that video out, because if you listen carefully, you'll actually hear what happens during the roam. Literally right in front of the access point. And you see we're minus 85, 86, right? So, I mean, this is you know, I'll let you step through to the next screenshot there and just kind of show, on the next slide, the layout here. Whenever you're doing these types of packet captures, we set both APs up onto the same channel. As Dan, you were talking about earlier, when you're doing the over-the-air sniffer, you know, you want to make sure that you can capture all the things on the air. In this case, this is an 11A generation device. So this is pretty straightforward. This is a PSK SSID in this particular example. But when you're doing these PCAPs and you're not using the tooling in Catalyst Center, you got to make sure everything is clock synced, because otherwise it's garbage in, garbage out. So the device is NTP synced, your laptop's NTP synced. I mean, all of this stuff is maybe, if you've done this before, it's trivial, but if you don't do it and set it up properly, and then I record everything, this is why I have this video from a couple of years ago. I record everything on the phone. So as I'm walking around, I can look at the clocks, I can see what's happening, I can hear that packet loss, I can look at the Wireshark afterwards and draw all these, you know, conclusions based on the exact time that I was over in this area and all that kind of stuff. So if you step to the next slide, you'll see kind of the evolution where we're thinking here. So we did all these PCAPs, right? And we got all these files dumped to the drive on the machine using this MacBook Pro, same one I'm on now. And okay, fair enough. We've got all these PCAPs. I'm looking at Wireshark. I can't really find anything that jumps out at me. Nothing totally obvious. I'm getting probe responses. I'm getting all the things you'd expect to do a roam, but I'm just never getting an association. So I pulled down a tool that we make available on DevNet called Wi-Fi Hawk. This is written by one of our escalation engineers, most senior guy, Javier Contreras. If you've ever gone to Cisco Live, Javier has awesome sessions on wireless troubleshooting. This is one of the tools that he wrote to help go into deep analysis on wireless PCAPs. So on the next slide, you'll see some of the logic here. So you take the PCAP that you grabbed from the laptop, right, or you got from an over-the-air sniffer, as Dan was showing earlier. You drop it into the tool, and it takes a bit of time, depending on the size of this file. It might take 10, 15, 20 minutes or more. If it's hundreds of megabytes, you might be at this for a while. It's doing a lot of work in the background, and what it produces is available on the next slide, which is a summary Excel spreadsheet, which is really, really handy, and it shows you all the APs that it heard in that PCAP on the left-hand side. Everything's hot linked, so you can go right to that AP and look at all the parsing of packets and issues that those APs are seeing. And on the right-hand side, you can see all the clients that it also heard in that PCAP, right? So this is just channel 36 in this particular example. And if you look at the one I've highlighted in red here, the next slide will actually show a deeper dive onto that AP specifically. So this is the AP that we were having problems with, that we were not getting connectivity to for this VoIP phone. And what jumped out immediately, and this is kind of like the aha moment we had, possible incorrect QBSS value. So this is a load metric in the beacon. And the basically call admission control, the available bandwidth is being marked as extremely low, right? So evaluate if this is a defect. Awesome. So if we go to the next slide here, you'll actually see what this looks like inside the PCAP. So okay, I'm like, oh, let's filter this down on just the beacons. Let's go and look at actually what's happening with the available capacity, right? Available admission capacity, which is part of call admission control. If you have Wi-Fi phones and you have CAC enabled, then part of that handshake of association is determining whether or not that AP can accept a call. Does it have enough free bandwidth or enough free time? And what I did is I put this available, I showed it as a column. So I said, like, here's all my beacons from every AP on this channel, the two of them that we're really testing against. And you can see here clearly that the admission capacity is 141 or 4,512 microseconds. What this is showing up as is vastly different from the other APs that are on the same channel. That's like an aha moment. Like, why is this different? This happens to be the same AP that's on the 9800. And then that led to some searching around call admission control and defects. And I think on the next slide, I actually show where that landed, which is an existing known defect, right back to what the Wi-Fi Hawk pointed to, which is evaluate if this is a defect. And sure enough, it was. And it was a known issue at this particular time, way back in 17.3 code, that was fixed in a later version and in some escalation branches as well. But this is just an example of going a little bit deeper, doing a little bit more analysis, and using one of our really cool tools in Wi-Fi Hawk to solve this roaming issue in the hospital that was really impacting, their migration planning and ultimately, save the day as far as getting that to be a smooth roam. So once we upgraded the WLC code and retested this, it was like a non-issue. So I thought that was a little interesting story from the field.
Yeah, that's good. So I guess the phone was set up so that, or configured so that if the channel wasn't good enough, if the utilization was so high, it wouldn't have been a good call, that it shouldn't connect.
Absolutely. And so what was happening was in parts of the hospital, you'd be right underneath an AP, where you're like, well, why can't I roam to this? What's going on here? This is the best AP I should be on. And you'd be turning a corner and you'd lose the call or it would drop. Because the next one wasn't yet available, right? So you'd have all these dead areas in a sense. So this was the initial testing, and then I was like, okay, we got to lab this up. And as soon as we put, A versus B, it was obvious. Every time we were on the AP on the AirOS controller, it was properly processing the admission control metric. It was immediately associated, like it would probe response, get the authentication, and away we go. The 9800 side, when we had this defect, the phone was basically getting in the beacon told that this AP is too busy to take a call. And so it would never even try to make an authentication request to the AP, and therefore we'd never roam there. If you sat around for long enough and there was no other parents or candidates available, sometimes it would hop on that AP, but it'd be very, very long delays.
Well,
so just kind of a quick recap. So basically the way the story went was, obviously you had some issues. You used Catalyst Center then to collect the PCAPs, right? And then you just ported those over to the wireless Hawk to do the analysis.
So the PCAP we did some initial triaging in Catalyst Center, right? To look at the basics, right? Is the things working? Do we have association or that kind of stuff? But when we started getting into the lab tests, and we were doing this for hours in a day there, we just camped out in the basement. I was using the laptop actually I'm on right now, which is an M1 machine in over-the-air sniffer mode, right? And in this scenario, we had only one channel to work with in the lab, and because we put both APs in the same channel, and it was an older device, an 11A generation device. So we could do a PCAP and actually look into things. And it turned out to be not a phone side problem at all. This was, like I said, infrastructure side.
Right. Okay.
But you could do the same with a file that you pulled down from Catalyst Center too, right, Al? You could run that through your Wi-Fi Hawk. If Catalyst Center isn't coming to any conclusions for you on the basics, there's a bunch of other anomalies that have yours programmed in that tool, which are really handy. And it doesn't have to be Cisco. You could be, if you have a problem with your home Wi-Fi, you could run it through this tool too, right? It's really cool.
Yeah. Yeah. Oh yeah. Good idea.
All right. Anything else, Dan or Ian?
I got nothing for you, Dan.
Okay. I love the real world example there, and thanks for joining us from the medical center there today. That's cool. Appreciate that. And Dan, I love the back and forth between kind of telling us, describing all the different options, and then the live demonstrations there in Catalyst Center. That was great. Thanks for that as well.
Yeah, sure. My pleasure.
And this was another great episode here. Thank you, Dan, Ian, for part 2 here, the deep dive on the wireless PCAPs. It looks like we're good on questions. We had a lot of good interactivity here. We had some love via Slido for Javier. So shout out to Javier. Love the example of the Wi-Fi Hawk tool. He's got some great options and tools out there as one of the premier escalation resources we have at Cisco. He's amazing to work with. So I guess I just would like to remind you, please go out. You can view this content. You can subscribe to our channel, youtube.com/@getunplugged, and turn on notifications. You'll be notified when we do go live with new great content. We do have a schedule up there for upcoming episodes as well. So right underneath the title bar of the channel and the graphic, you can click on the first link and you'll see the upcoming schedule for future episodes. And but if you subscribe, turn on notifications, you're good to go. You'll be notified when we do go live. But with that, thank you, Al, for helping me again, co-host. And
Yeah, it's been fun here with Hagrid and Dumbledore. So
exactly. Got some
the wizards of Wi-Fi.
some good references here. I was cracking up also at the Proclaimers reference here. We had the I would capture 500 meg and and 500 meg more. So I was saying that line to the song music there in my head when I read it, but that was pretty funny as well. But thank you, everyone. Another great episode, and until next time, stay connected and unplugged.